Okay, so we are looking at work, energy, and power. Work, energy, and power. We have defined and described what work is. We have defined and described what energy is. So let's now look at the last part, which is power. What is power? Power, by definition, is simply the rate of doing work. Power is defined as the rate of doing work. The SI unit for power is what? So after the calculations we'll be involving ourselves with under power, the unit that I expect you to write is what? Okay, W. Of course, as we go on, I need you to get familiar with the, the related units like kilowatts. Okay, you need to know how to convert from watts to kilowatts. We'll talk about that one as we go on. So because it is a calculation, it's a quantity that can be calculated, power also has a formula. And the formula is what you are seeing on the screen. Power is equals to work over time. Or you can actually use work and energy interchangeably. So power is also given by the formula energy over time. Now, if you remember the two lessons that have preceded this one, we said work is measured in joules, okay? And energy is also measured in what? Energy is also measured in what? What's the unit energy is measured in?
Joules.
Exactly, it's also measured in joules. So can you see that there's a, there's a correlation there, it's similar. They can be used interchangeably. So sometimes you have a question that requires you to calculate the power, but they have not given you the work. What they have given you is the energy. You will still use that energy to calculate the power. Okay. So the P represents power, the W is the work done, T is the time taken, and of course, E is the energy in joules. Guess what? This is the end of power. The topic is done. So let me give you an example just to cement your understanding. Here's an example on how you can do these calculations for work, energy, and power. Okay. So a crane can lift 200 kg to a height of 100 meters in 20 seconds. So do this example together, and then I'll give you some work thereafter. The first question says, calculate the weight of the crane. Limpo, what's the formula for weight? What is the formula for weight?
It's mass times gravity.
Okay, so weight is given by the formula mass times gravity. Okay, so we are saying weight is given by the formula mass times the gravity. Okay, now when you look at our question here, what is our mass and what is our gravity? What's the mass what's the mass and what's the gravity here? The mass is Z.
What is happening?
Okay, I can't get anyone. Alice, what's the mass?
200 kg.
Very good. And what's the gravity?
10.
Okay, so very good. So the mass is 200 kg. And you need to be careful every single time the mass has to be in kgs. So when you do the math here, 200 times 10 gives us 2,000 newtons. So in other words, our answer for the first question is 2,000 newtons. The weight of the crane is 2,000 newtons. Let's go to the next part. Calculate the work done. Calculate the work done. Again, the formula is the most important thing. Andrew, what's the formula for work?
Let me just a bit.
No. What's the formula for work? So let the formulas be in your mental schematum.
Work is equal to power times time.
No, we said work is given by force times distance. Okay? Are we together, Andrew?
Yes.
Okay, don't forget that, eh?
Yeah.
So what is our force? Our force is what we are just from calculating, the 2,000 newtons. Multiplied by, now what is the distance? According to our question, what's the distance or the height here? It is 100 meters, okay? So which means we are just multiplying 2,000 times 100. What does it give us? What does it give us?